our lab title is going to be Hypokinetics. What we're going to do in this lab is we're going to actually determine the kinetic order of a chemical reaction based on data that we collect. So the question that we need to write down, and by the way, everything I'm writing needs to go in your lab notebook, is what is the kinetic order for the thiosulfate ion from a reaction with hydrochloric acid. Now, there's a bunch of background information we need to know for this particular experiment. We have to actually know what the chemical reaction is. So now we're going to write down the background information of the actual reaction. And the reaction is with sodium thiosulfate. And it is initially aqueous. It looks like just a clear solution. And it's reacted with 2 moles of hydrochloric acid, which is, of course, aqueous, another clear solution. And then what you're going to be doing is you're going to be producing solid sulfur plus some sulfur dioxide gas plus, ooh, we ran out of room. Hopefully you guys have enough space. Water, liquid water, and 2 moles of aqueous sodium chloride. Now what we want to do is we want to actually write this out as an ionic equation. So I'm going to write it out as an ionic equation showing all the aqueous salts dissociated, or in the case of the acid, ionized apart. So what I have are 2 Na plus and just 1 thiosulfate ion, S2O3 2 minus, plus 2 H pluses, 2 Cl minuses, coming together to produce solid sulfur. Notice I don't have to write a charge because it's obviously not a salt, it's dissociated. And the same with the sulfur dioxide. Same with the water, it's molecular, so I don't need to dissociate and write charges. But I do have to write out the ions for the sodium chloride. There's 2 Na pluses and there's 2 Cl minuses. So again, I've taken a chemical equation, I've written out an ionic equation, now I need to write out a net ionic equation. So I have to look for my spectator ions. Remember, spectator ions are the ions that are the same before and after the chemical change. So we have 2 Na plus, 2 Na plus, 2 Cl minus, 2 Cl minus. So now I can write out the net ionic equation, which is a lot more manageable for this reaction. So it's S2O3 2 minus plus 2H plus produces solid sulfur, sulfur dioxide, and water. And that's it. So this right here is the net ionic equation for the reaction that we're going to be doing. Now you'll be doing the chemical reaction in this tube here. This tube is called the centillion tube. It's got a fancy name. What's nice about it is that it's got a flat bottom, so we don't need a test tube holder for it. And it's cylinder, and of course we can add our volume. What we're going to do is we are going to measure the rate of the reaction by how long it takes. We'll have an X on a piece of paper, the same X. We'll put the tube right over the X, and we'll add the reactants, the sodium thiosulfate and the acid, and those two are going to react together to produce solid sulfur. That solid sulfur eventually is going to block out the X that we've drawn on our paper. When that happens, we'll stop the timer. And the timer that we're going to be using is going to identify for us the rate of reaction, because it'll tell us in seconds how fast it's being reacted. Now what we're going to do, below our background information, we're going to write out the materials, and then we're going to begin with the procedure. So the materials we're working with, we obviously need sodium thiosulfate, and we're going to be working with 0.15 molarity of sodium thiosulfate. That, of course, is the thiosulfate ion. We're also going to be working with a pretty strong acid. We have to be very careful with it. It's 6 molar hydrochloric acid. And I'm just going to write, those are the first two. The next one is going to be a centillion tube, but I'm just going to put it as a glass tube. We're of course going to need to use a stopwatch. You are more than welcome to use your cell phone in this particular lab for timing. Now the procedures that we're going to follow is that we're going to first, of course, obtain our materials. Now based on the data table that you're eventually going to write out in your data section, you're going to want to figure out how much of each solution you're going to need to get. And you should just collect it all within a beaker, and the beaker is going to be your stock solution with which you could do your mixing using pipettes. So actually, let's add a couple more materials. Let's add pipettes. You're going to need 2 of them, and then 2 beakers would be fine. And the beaker size doesn't matter. Okay, so what we'll do is we're going to write a large black X on a piece of white paper. I'll have white paper available for you in doing this lab. Okay. Next, what we're going to do is we're going to place glass tube on black X. And that's where we're going to be doing all of our chemical reactions. The first one we're going to do is we are going to mix the following. We're going to take the stock solution, which is 0.15 molarity of the sodium thiosulfate, and we're going to start off with 20 milliliters of it. So add 20 milliliters of Na2S2O3 to glass tube. Then what you're going to do is you're going to get your stopwatch ready. Start stopwatch once 5 milliliters of HCl is added to the glass tube. Now there's something else I want us to write down in the materials. I'm also going to be providing you with a graduated cylinder so that you can make all of your measurements for the volume. Number 4, what you're going to do is you are going to stop the timer, the stopwatch, when the X is no longer visible. Now, you're going to have to make sure for each task that you do that you are consistent about the decision you make for when you definitely can't see the X anymore, when it can't be seen. So you should have the same person making the observations every single time. Now, number 5 is simply to repeat this process, numbers 1 through 4, for different dilutions of our sodium thiosulfate, Na2S2O3. Now those different dilutions are going to be done in a table. And I'm not going to make the table as neat as what I would like you to make it. I'm just going to be doing it freehand. But I'd actually like you guys to use a ruler when setting up your data table. So you're going to have trial number, you're going to have the volume of the 0.15 molarity sodium thiosulfate in milliliters. You will have volume of H2O you will use for your dilutions in milliliters. And then you will have the time, which we're of course going to be measuring in seconds. Now we're only going to be doing a couple of trials. We're only going to be doing 5. And the first trial is of course with just 20 milliliters of the pure sodium thiosulfate. Then of course we add in the 5 milliliters of acid. There's going to be 0 water in the first trial. The second trial, we're going to dilute down the sodium thiosulfate, so we have 15 of our original stock solution and 5 milliliters water. Make sure you use deionized water in this lab. Number 3, we're going to have 10 milliliters and then 10. And you're probably getting the hint already that what's going to happen in this particular lab is we're going to end up eventually with 0 of the sodium thiosulfate and then all of water. And I can tell you pretty much what your answer is going to be right here, because you're not going to end up with a reaction. You, of course, should have 0. Basically, this you're not going to collect any data for the 5th trial, because you're not going to have a reaction if you don't have any sodium thiosulfate. Okay, then below that, what you're going to do is you're going to have to eventually do the table again with a trial number, but we're going to begin with the concentration, and I'm going to call it the initial concentration for each reaction you do during each trial of the sodium thiosulfate. So above you're given all the various volumes. Now what you're going to have to figure out is what in molarity was each trial for the sodium thiosulfate. And then you're going to write it down with the corresponding time. Now I'm going to deviate from the lab notebook. So this is just notes. Don't forget to figure out dilutions. M1V1 equals M2V2. So for each of our trials, we're always beginning with 0.5 molarity. So if I wanted to figure out the molarity for trial 2, I'm beginning with 0.15 molarity. That would be my M1. The volume that I'm using of it is I'm using 15 milliliters. And the final volume after I add 5 is, of course, going to be 20. My final volume for each of these trials is always 20. To figure out the molarity after I've done that dilution, I have to solve for M2. So I'm going to divide by 20 milliliters on both sides. Milliliters will cancel out over here. And then you're going to take your calculator. And Mr. Barron's brain is definitely dead right now, so I'm going to type it in myself. And I find that the molarity for that trial 2 is actually 0.1125 molarity. And that's for M2. So in trial 1, I know it's my initial, what I started with, 0.15 molarity. Trial 2, I just did my calculation using the M1V1 equals M2V2, which is now 0.1125 molarity. And then you want to fill in the rest of your table. I will not let you begin your lab unless you have filled in the rest of this table and you're prepared to collect data in this experiment. We will do the conclusion together as a class. We're going to tie this in with some of the book problems and the worksheet problems that you've been doing in this class. If you have any other additional questions, please see me during tutoring.